For supervised machine learning, we're trying to construct a function f by modifying its model parameters. We seek to modify these model parameters such that we're going to lead the greatest reduction, the lowest value for some sort of cost or objective function. We saw that for linear regression. We saw that for that model, there are these beta coefficients associated with each feature of our data set. And our objective function for linear regression is the mean squared error. So what are the best set of beta coefficients to use for our model is going to lead to the greatest, the lowest value of our cost function, in this case the mean squared error. When we talk about other models, we'll discuss what are the objective functions we're trying to reduce. And not only that, what are the model parameters that we're going to modify to reduce this cost function. When I say we're going to modify, I really mean scikit-learn underneath the hood when you invoke the fit method. What is it doing? What are the parameters it is modifying to try to lead to the lowest possible cost function? Now for this notebook, we're going to look at the California housing data set. So we're trying to predict the median home price for each census block. And we have characteristics for each census block. Things like the median income, the housing age, things like that, as well as the latitude and longitude. So 8 characteristics, 8 features for all those observations. Now it can be a bit daunting to choose an initial model to work with for your problem. Scikit-learn is going to have this nice cheat sheet or this nice flow chart where you can go ahead and use to decide what's a good model to start off with. Now the models they suggest here aren't written in stone. In other words, you shouldn't view this as the correct answer or the only answer. It's just more to be used as a guide, an initial model to use for your analysis. And there is rationale how it's making these decisions, and some of these decisions that it's making will make more sense as we dive deeper into these models. We talk further about some of these other popular models for machine learning. Let's quickly look at this flowchart and try to make sense of it. So the first thing you're going to ask yourself is, do you have more than 50 samples? If you don't, the flowchart suggests you get more data. And the reason why is because it's really hard to have a really good model if you don't have many observations. Think of the way that we learn. The way we learn is we see some observations with some labels, and we can take those observations and learn from them, find the pattern that's involved. But if there are not many observations, not many examples, then it's really hard to learn. And sometimes I understand getting more data is easier said than done, but just keep in mind that these models, well, they need examples, and the more examples that you have, that you provide for it in general, the better it's going to be. The next thing that, if we follow this flow chart, is going to ask, okay, well, you're trying to predict labeled data, in other words, categories, classes, or you're trying to predict some sort of quantity, some continuous value. And the reason why it's asking this question is because it's going to decide, depending on how you answer this, whether you have classification or regression, those two main branches of supervised machine learning. And the other part of this flowchart here describes unsupervised machine learning. We'll talk about later on. You're going to use unsupervised machine learning when you don't have labels for your observations. So notice one of the questions it asks is, do you have labels? Do you have the values for what you're trying to predict? If no, then you have to go ahead and do unsupervised machine learning. You're restricted to only doing unsupervised machine learning because you don't have the labels. Now let's focus on the California housing data set, and let's do some initial exploration with the features we have. So let's go ahead and plot the value we're trying to predict, the median home value with each of the features. So that's what we have in this interactive visualization. With this tab here, you can go ahead and change and modify the feature you're plotting against. So if we quickly look at this, one of the things that becomes apparent is that the median income perhaps has the strongest correlation, linear correlation. But let's look at latitude. So we look at latitude here. We have a situation where, you know what, using a linear regression model perhaps won't make best use of this of this feature here, but let's use a nonlinear model. Nonlinear model can perhaps capture this nonlinear behavior that we see with regards to latitude. So let's go ahead and do that for the next example here. We're going to focus on decision tree model.